Okay, great. All right. So, um, what I wanted to talk about today is kind of not so much a hardcore infosec topic as much as just some reflections on the things that I learned over the past couple of years as I've kind of made machine learning sort of a hobby for myself. Obviously, it's a very hot topic. And some of the things that I learned I thought might be kind of applicable. So send in some thoughts to Joe, and he was kind enough to accept it. So um, just wanted to share that, and definitely would look forward to any feedback or comments that you all have. So with that, let's jump into it. So this is me. I'm not super active on the infosec Twitter sphere. I do read it a fair bit, but don't really post anything. Actually do have an account, little known fact. So just wanted to share this really quickly. This is my kind of background and experience. Most of my experience was at iSight, kind of started there pretty early on as part of building that. And now I'm at FireEye. By way of educational background, got mostly focused on intelligence, both graduate and undergrad. And let's see. All right. And sorry, I was just pulling up the chat here. And this is what I like to do in my free time, spend time with the family. Machine learning is kind of a hobby. I like to play chess, read a bunch of different stuff, and play soccer or football, depending on where in the world you're from. And I've done a bunch of different things, had a bunch of different roles, but mostly on the analytics side. So kind of if you want to kind of classify my background as one thing, it's probably closest to kind of an all source analyst. All right. So I'm not really going to be diving super deep into what machine learning is and getting really technical, but just wanted to spend a couple of minutes just setting the groundwork because it's not something that everyone necessarily focuses on day to day. So one thing that was interesting to me when I learned it is that AI is actually the more general term. So AI is a general term for systems that make decisions, and it includes things like hard-coded expert systems. So if you write some kind of tool that has hard-coded rules that some kind of logic flow, then under the definition of artificial intelligence, it actually fits the definition. But machine learning is something a lot different, or goes a lot further. It means that you create an algorithm that actually learns based on examples and not based on hard-coded rules. So the algorithm is not depending on what you tell it, but it's actually inferring those things from the data, and that's what the algorithms are all about. How do you build algorithms that can kind of infer something from the data? And then deep learning is a branch of machine learning that's actually behind a lot of the recent advances in things like image recognition, computer vision, speech recognition. So when you talk to your iPhone, it's using, and it recognizes what you're saying, it's using deep learning, self-driving cars, smart assistants, all that stuff. And there's a lot of really interesting things that ML is doing right now. It's moving super fast. You're familiar with all these companies, I'm sure, right? eBay, Tesla, Snapchat, Apple, Amazon, Google. Um, and for a lot of them, it's pretty obvious what they're trying to do with machine learning. One maybe little known fact is this pretty interesting study that was done on eBay. So eBay has automated translations for postings, and after they launched that feature, there's a study done that found that it increased U.S. exports from eBay to Spanish-speaking Latin American countries by 17.5%. So that was kind of interesting. And I should also qualify this by saying, with reference to Snapchat, I don't know if you consider Snapchat filters to be meaningful progress or not. Some people definitely do, but maybe not in this crowd. All right. So one key point that I would like to ask you to also keep in mind is that in the current state of machine learning, it's extremely good at prediction problems. And what that means is that if you can figure out a way to give the algorithm meaningful data on which to base a prediction, they're really good at sorting through that data if it's kind of if you can filter it down to a very specific decision point. They're not good at open-ended problems or sorting through um, a bunch of related problems or decision points that are not tightly related to a specific prediction problem. So the implication here is that it's really important to break down the problem into very specific pieces, and you can see this in everything from self-driving cars um, to things like to speech recognition for another thing. But also you can work backwards from features that are needed for the final prediction, right, through to various types of intermediate models. So this is what you see in very sophisticated systems, that it's not a single, quote unquote AI, as gets portrayed in popular media, but instead it's a whole ensemble of various types of models that are each specialized in a very particular part of the task, and together they work together to solve the problem. And so one of the really kind of high level takeaways is that people talk about general AI or strong AI, and we're a very, very, very long way away from that. And there's actually a strain of thought in the field that because deep learning in particular has been so effective over the past few years, that it's actually created like a gold rush into that specific type of technology, which might be hampering longer term progress towards a more generalized approach, because a lot of people believe that kind of the specific deep learning approaches that we have today based on neural networks are not, like, there's just no way those are going to jump. Like, we need a completely different innovative approach to artificial intelligence in order to actually get to general AI. So anyway, general AI is one of those things that's always 5 to 20 years away, and it's been 5 to 20 years away for the past 50 years. So all right, but you can do a lot of really cool things with it. So this is the what's known as the Yolo framework, which stands for you only look once. And this is a picture that I actually took in India, and so I ran it through the Yolo classifier, and you can see it's pretty good, right? Like identifying motorcycles, people, even this little traffic light, and very fast. And this is the type of technology, a lot more sophisticated, obviously, but that is being used by Tesla and a lot of other companies that are working on self-driving car technology. That's obviously a gross simplification, because this is super simple compared to what they're trying to do and all the decision frameworks and pieces that they're trying to put in, but same sort of technology. So it's pretty cool. And then I thought this was kind of funny on the left-hand side here, the PowerPoint caption, a person riding a motorcycle on the side of the road. So if you didn't know it, whenever you put a picture into PowerPoint, it runs that through a computer vision algorithm and gives you suggested captions. So fun fact. All right, but one thing I did want to highlight is that we still need a lot of progress for self-driving wagons. That doesn't really work very well, although it did correctly identify my daughter here as a person sitting in the wagon. So I don't even know what this contraption is called, but she likes to ride it down the driveway. So there you go. And there's also a lot of problems with machine learning and artificial intelligence in general. These are just two, I could have filled up this slide with tiny text with all the issues and problems that have come about or that people have identified. But there's a lot of issues with kind of turning over decision making to an algorithm, because obviously an algorithm is not ethically aware, and but at the same, even though the algorithm itself is obviously not ethically aware or aware of anything, it still can embody the implicit biases that are present in the data that's used to train it. So this is a huge ethical issue in machine learning right now, because a lot of these things have kind of come to light recently, and there's a lot of, especially as artificial intelligence becomes more pervasive and powerful, as compute and processing power becomes more cheap and readily available, then you have lots of issues and people are, in my view, a lot of people are concerned about, what does it look like to live in the kind of surveillance state or panopticon that is, becoming increasingly possible. And if you look at, some countries around the world, is already largely been instantiated. So how do you think about those types of problems? It's a difficult problem. Once the technology is out of the box, it's really, really, really hard to put it back in, as we all know. And there's also some, thought this was just an interesting thing to point out here. There's a lot of work that's been done to apply machine learning to a lot of different types of technology and infosec problems. But it's not perfect, right? There's a lot of ways to attack it. Some data scientists from FireEye published a paper a couple of years ago looking at adversarial examples for malware detection. More recently, a company named Skylight did this whole expose where they talked about how they were able to fool a really popular, quote unquote, machine learning based endpoint technology by just appending a bunch of strings from benign binaries, and then that was fooling the classifier. There's a lot of ways to get around that, and different approaches to, tons of different ways to build, machine learning based malware classifiers. But anyway, definitely something that is interesting and important to, and I'll come back to this point, both for as it relates to the bias and as it relates to these adversarial attacks a little later on. Okay, so that's a quick summary of, my super rapid fire survey of the field. So I want to talk a little bit about how I got into this. And this was me 2 years ago when I realized that there was just a lot of problems that we were facing from a data perspective, especially as it related to just unstructured text and data, where we needed to figure out how to rapidly, make sense of all that data. And, hiring, armies of analysts wasn't really a great option. So I realized I was going to have to hire people to work on this. And I didn't want to hire somebody for something that I knew absolutely nothing about, because this really was me when it came to machine learning a couple years ago. So this is what I did, and where I started. So I started with this online class called Fast AI. You can literally go to fast.ai, just type it in your browser. It's really great. And I took the class that's taught by Jeremy Howard, the guy here on the left. He and Rachel Thomas created this whole program. They also teach at the University of San Francisco and have done a bunch of other things. But I found it to be immensely helpful and illuminating. And Jeremy is a fantastic teacher, so I really highly recommend it. It's not a replacement for getting a computer science degree or getting a degree in data science. But if you are capable of coding a little bit in Python, you can follow along, and you can, within a couple of hours, I had built a classifier to, distinguish between cats and dogs, which tells you probably more about the state of the art. Well, definitely tells you more about the state of the art and how fast it's moving in machine learning than it does about anything that I can do. But it's like they do a really fantastic job. So one of the first things that I built was a classification model to try to make sense of a bunch of the data that they were seeing constantly on Payspin, because people post things that are interesting on Payspin a lot. And there's also a lot of stuff that's not interesting at all on Payspin. But enough interesting stuff that it's worth looking at, okay, well, how can we kind of pick those needles out of this haystack in some kind of scalable fashion? So basically what I did was I wrote a bunch of YAR rules and ran them against a big collection of data from Payspin and a bunch of other pay sites, and then used that to basically get candidates for different classes that I was interested in. So you can see I named this one email and pass. Basically is looking for examples where you could see people posting like emails and usernames on Payspin, for example. And so wrote a bunch of these types of YAR rules to collect the data. Ran it, I think it ran it against like 1.3 million pastes or something. And then mind numbing is actually the technical term for this. But if you do get involved in any kind of machine learning project, you'll probably run into this issue of getting labeled data, or how are we going to basically get enough samples that are labeled in a way that we can actually train a supervised classification model. So that's a big deal. It took me a lot of time to do some of this, but it's the only way, and usually you have to label the data by hand in some fashion. So then train the model, identify problems, and kind of rinse and repeat. As you identify problems, you kind of say, oh, now I have to go back and retrain the model because I did this, made this dumb mistake, now I have to go do it again. Also did things like this. This is a Kaggle competition. So if you're into data science at all, you know about Kaggle. If not, and you're interested in getting into data science, definitely check out kaggle.com. Lots of really interesting things. And you can learn a lot by looking at the ways that other people have implemented solutions to various types of machine learning and data science problems. All right. So as I said, I was looking at Payspin. So one of the things that I did was I trained a fast text model on this big trove of Payspin or pastes that we had. And so 3.3 billion words. But what's really interesting, and I don't really have time to get into like word embeddings and how, representations of text, but basically the idea is that you can create vector mappings for words in such a way that the vectors actually have some kind of relationship to the meaning and the way that we use words. So you can do things like analogy reasoning. There's a really famous one where you can basically measure. So basically you map all the words to some arbitrary vector space, and then you can do mathematical operations on those vectors using like matrix algebra. And what's really interesting is that you can find relationships between words in such a way that suggests that there is some actual sort of meaning. So for example, if you you can basically show like in the data that, for example, like man is to king as woman is to queen, for example. There's a bunch of other things you can also take like capitals. You can say like London is to United Kingdom as Paris is to France. In this case, this is just kind of a silly one, but I took politician is the police as what is the hacker, and the top suggestion was super hacker, which I thought was funny. The next one is fembot, which is really weird and also highlights some of the data bias issues, right? Like, so there, this is a representation of what people posted on Payspin, which means that there's a lot of things in that data. All right. So these are the different classes that we're kind of looking for. We'll go through all those, but anyway. So we got it to like a 99% plus accuracy on these classes, which is pretty cool. And so here's the class. So it's somewhat imbalanced classes, which if you've looked at machine learning problems, can be a challenge, especially with the less representative classes. But overall, it seemed to, the approach seemed to work pretty well. And then I thought this was kind of interesting. This is an example of, so we had one classification or one class for our model that was fiction. It's because people post random fiction on Payspin a lot, unfortunately, and a lot of it's really terrible. But so you can see this. This is a real snippet from Payspin, but you can, and it's way longer than this. You can see below it's the confidence of the prediction, or the confidence of the model in the prediction. So predicted that it was fiction and with a confidence of 0.925. What's also interesting is if you map it out, like if you kind of sequentially truncate or take larger and larger chunks of the text. So first you take, the first 100 characters, then then the first 200 characters, then 300, then 400, kind of iterate through that range. You can see how the model's confidence in those predictions changes as it gets, a larger and larger sample, which again goes back to the point of, the model needing to be trained on data that's representative of the types of things that you're likely to see in production. We also worked on some neural machine translation. So I'll spare you all the details because this was a long and drawn out process. So basically we're trying to translate from Russian text to English text. So did a lot of hunting for parallel corpora, because basically what you do in a problem like this is you take text that, you train the model on, it's a sequence-to-sequence problem, right? So you train the model by feeding it a sequence in one language and then training it to output a sequence in the other language. And that means that the model has to learn some kind of meaningful representation of the relationship between words in both those languages. So I was able to gather 47 million lines of text, mostly from UN documents, TV show subtitles, and news articles, and then a small set of manually translated in-domain text that we had actually translated in-house, and then used that. So it learned a little bit of the vocabulary. And there was a lot of data wrangling involved in that and days of GPU time. But what came out was something that was actually sort of useful. So here you can see this Russian text, and it's from a threat actor writing in Russian about a malware project that he was working on. But what's really funny is there's some really funny things that come out. So I don't know what spending your way into a mammoth means, but that was one of the things that the model came out with. But you can also do a lot of things like here you can see I used a software system called Sockeye. It's a sequence-to-sequence library. But you can see this is a much better translation because it's made by averaging the predictions from several different checkpoints of the model. So basically several slightly different versions of the model, combining the predictions together. And you can see the Google translation up here above. So, the actual result that we got wasn't that much worse than Google Translate, and we're able to do it in-house, then integrate it into an internal application that we had. And then there's some more advanced things that can be done. This is something that I messed with a little more recently. But basically, you can do some really, really cool stuff if you take with some of the transformer models that are available now. So for example, I took this Roberta model, which was created by Facebook AI research team. And then basically you can give it hypotheses and you can give it a premise and then a hypothesis, and it will tell you if it thinks that the hypothesis follows from the premise. So basically, I'll show you right here. So you take this original sentence, context here, which is just a sentence from a news article, the notorious Saudi Arabian Armine group, etc. And then pull out the named entities, Saudi Arabian Armine, and then plug that into one of the hypotheses. So you can see back here, right? So we just use string formatting here. So we put it in, and then basically take the most confident one that we have. So in this case, the sentence that the model thought was most likely linked to the context was this one: Saudi Arabian Armine conducts cyber threat activity. So kind of cool. Not super useful in this. This is more of kind of just a proof of concept, but you can imagine a lot of interesting use cases to exploiting large amounts of data at scale, and then being able to make meaningful inferences in terms of what you're pulling out of that data. All right, so that's kind of the things that I did. I wanted to give a really quick summary of things that I learned in that process. So One of the things that was really clear is that both data science and infosec, or cyber intelligence, or whatever branch of information security you're in, are really team sports. And much like most other team sports, and really organizations in general, not everyone has the same function, and that's a good thing. So one of the things that I learned was that in a lot of these projects, different types of people with different types of backgrounds have different strengths and different ways to, look at problems. So, for example, like data scientists are usually going to take a long-term view. They're going to want to take the right approach. They're going to want to, design an elegant solution. Software engineers are really important. They're going to build much better tools than somebody like me who can hack together some Python code, and that's pretty much it. And you want people who have kind of a hacker mindset as well, because they're the ones who are going to get you really quick results over the weekend sometimes. And you want all those types of mindsets, but you need more than just one type of person, right, to solve a lot of these difficult problems. Another thing is that training a highly accurate model does not usually equal solving your problem. So it's worth really thinking through upfront, what's the actual definition of your kind of business or process, or whatever your security problem is. It's also easy to get enamored with the technology and just try to solve problems for their own sake, and that doesn't always result in something that's actually going to be meaningful or helpful to you and your organization. Although maybe it's fun, and if it's a hobby, that's cool. This is kind of where I wanted to get back to the to the bias question and some of the ethics. Data in machine learning, it's almost everything, right? So machine models are in some sense really just a distillation of the data into a format that you can use to make predictions on new data. So the data that you have is really, really, really important. And if you don't have good data, it's going to be a garbage in, garbage out type situation. One of the things that's really cool in the last few years is that transfer learning has really taken off. And that lets you leverage models that have been trained on, in many cases, Roberta, for example, is trained on 160 gigabytes of text, which means that you can kind of take some of that, latent learning in the model and apply it to a new problem with much better success than trying to train something from scratch. And it's less susceptible to overfitting, which is nice. And if you try to build a model, you'll probably learn all about overfitting. It's fun. And then, I just do want to emphasize this point. Like, machine learning has never been more accessible. So, if it's not something that you're interested in, that's cool, whatever floats your boat. But if you are, and if you're interested and motivated, there are lots and lots of resources out there, and lots of people who have run into a lot of the same problems that you have. And there's really, it's really accessible. So don't let a fear of it not being accessible hold you back. It's definitely accessible. And these are some of my takeaways. I won't spend a lot of time on this, but generally, these are things that I took away that I kind of feel generally, but the things that I've done and the projects that I've worked on with, relating to machine learning and data science have definitely kind of highlighted these things, for me. So I know we're coming up on time, so I think I will leave it there, and open it up for any questions.
No, that was really good. That was probably one of the more informative and helpful presentations I've ever seen on the subject. So thank you so much for that. I think the feedback I was seeing in chat really echoes that. In the Q&A window, is there anything? As I didn't see anything in chat.
Let me pull up Q&A. All right. I don't see any specific questions in Q&A.
Okay. Yeah, but I think just the identification of the resources, and especially like the emphasis that, trying to come up with a perfect model, like the data scientist perspective, is nice, but probably in most instances not useful. Going back to that idea of, the perfect is potentially the enemy of the good, or the good enough in this case. So that's always something to look out for, I think, especially from the hacker mindset, as we're just trying to get to good enough.
Yeah. I think it's, there's always that balance, right? And sometimes you need something fast now, and then you need to do something better, later.
Mhm.
And I think that's why having a mix of people is really, or a mix of people with different backgrounds can be really, really powerful.
Okay, quick request to get back to the final thought slide for just a second.
Sure. Let's see. This one?
I think one more. Maybe not one more.
This one? I think it's this one. Okay.
Okay,
Is this the one you meant?
it's in chat. So, Mr. Lester, is that the one you were looking for? Yep. Okay.
Okay. Cool.
Yeah, continually work myself out of a job. That's always the best way of putting it. Like if I have to do it more than once, I should probably be scripting something, right?
Yeah. So one of the things that I read that really kind of stuck with me is a quote by John D. Rockefeller, who, one of the, famous robber barons of American history. So whatever you think about him or his company, one of the things that he said that was really interesting was that the first rule of everyone who joined Standard Oil was to figure out how to get someone else to do your job and then think about how to make more money for the company. And that's a very kind of like, money-driven capitalistic way to put it. But I think it's a really good principle in general.
Yes. Well, and especially now within this field, as just the sheer amount of data becomes so large that the idea that any one or even a team of people can actually go through it manually is rapidly disappearing. And so without
Yeah.
incorporating these sorts of techniques into play, they're just going to get buried before you're able to actually extract value.
Yeah. Okay. Seeing a question. What are you seeing and hearing out there on how orgs are realistically handling the bias issue? Yeah. So that's a really good question. I mean, it's probably less of an issue for a lot of infosec related things, right? If you're trying to classify malware, you're less concerned about that. Or if you're building a model that's going to, decide who, has a successful credit application, right? There's a lot very different real world impact there. I think people are trying to address it by thinking through, the data for one thing, right? To kind of go back to that point. So if you're using data that's biased to make your decision, right, then the model that you train on it is going to be biased. So I think there's things what people are trying to do now is to understand, you know, maybe your model is trying to predict some outcome, but maybe that outcome in the real world is conditioned on the biases that people have. And so your model learning from the decisions of those people is maybe not the right answer. And I think like the whole, deciding who gets parole, for example, like those types of problems is really applicable for that.
And Jayce, you said you do this in your spare time. This isn't something that FireEye is taking on.
Oh no, so yeah, so I mean, I didn't really want to talk about all the stuff that other people at FireEye are doing.
Gotcha. Okay.
But yeah, I mean, we're doing a lot. So we have, we've got machine learning models deployed to, for malware classification, for our endpoint stuff. We've got models deployed to, automate some of the more easy, alert disposition type things. And we have some really good blogs actually about some of that.
Very cool.
Yeah. And then deep learning could hamper progress. Well, I mean, it's not that it hampers progress itself, but rather that it may be a dead end in the search for a general, all-purpose AI.
Okay.